speaker is Jun Murai, who comes to us from Japan. And much as Peter is widely recognized for his contributions to bringing the internet to Europe, Jun has done similar things in his home country of Japan. He is going to talk to us today about the IoT more broadly in Japan, and perhaps talk about some significant deployments that they're either contemplating or actually doing. So,
okay.
about 20 minutes or so.
Yep. Okay. Thank you, Bob. I'm gonna talk about basically from the point of view of deployment of the IoT and other technology, related technology, mainly in Japan, but not necessarily in Japan. Let me start. Okay, so this is something like a conclusion now that, what I think is going to be, key actions for the deployment of the IoT, which is basically the architecture, sophisticated architecture is going to be necessary. And those existing internet and the web architecture, creating the harmony with the existing one, that's another issue. The technical standards, it's for the open kind of deployment is going to be necessary. And also the very important part is vertical deployment and then a horizontal open platform. So the agriculture, medical, and those areas going to be very, very much getting the benefit of IoT. But the very important thing is that we do have a open platform, so that very similar to the quiz discussion about the silo and vertical, horizontal type of thing. So open platform is necessary. And the trust and security, of course, the key issue. But when we are talking about the security, then it's talking about the risk, but also it's always a balance of the benefit and the risk. So that balance is really the important thing. Okay, so where to start with the IoT discussion is basically we are assuming that the internet is there, so that everybody participating on the internet, and then each of the devices tend to be starting with the RFID and other things, proprietary communication and other things, but now it's a kind of full spec of the TCP/IP loaded computers can be a thing, and including the smartphone and everything. So, and also the processing of the huge data generated from the things can be processed with various sophisticated way with parallel computing on the internet thing. So, and then any services can be created on the internet and the web architecture, I believe. That's basically what we are viewing today. So looking back, I visited the Stanford University in the early 80s, and then I was amazed that they are working on a philosophy class with the computers and putting all the text and then analyzing the work. But then also the artificial intelligence on the first phase was analyzing the language. And I remember that everybody was talking about the language being English, but my language was Japanese, so a little bit different that time. So language dependency is still going on with the web. Web pages are, analyzed after the web ages, but it's still on English, Japanese, Chinese, different languages are doing a little bit different thing. But the images analysis happened on the various search engines and other things. So now this is getting a little bit different from the language context to the image context, and then IoT. IoT is a data. So it's really more toward a neutral object to analyze and then understand. So this is basically another aspect of from a technology point of view, to talk about the IoT. So T is a thing, but we in Japan and our research group started with finding out the first drop of the rain and how we can find it, and then it's on the top of your head, and then there is a rain. And the second person said, "Oh, yes, it's a rain," and then identifying. But what we wanted to do was the first drop of rain. It's going to be a front glass of the automobile, and then the driver started to move the wiper, and then collecting all those location, and so human driver being a sensor. That was what we wanted to achieve, and then from middle of the 90s, and we successfully deployed as a test in Nagoya city for the modern 1500 taxi cab equipped with a GPS and packet network, which was very expensive by that time. And then we started to work on the internet car. So now that was the concept that any rain and the speed, car navigation, traffic, and so many weather authority of Japan hated us. Police hated us because it's generated with a kind of bottom-up manner of all the data should have been considered as a kind of a government authority, but it was actually generated from people. So that was the concept. But finally, that time, well, we did the standardization among the automobile, even among Nissan, Toyota, Honda. Then we worked together, and then we set up the format. It's very difficult to repeat that effort again. But then it was deployed, actually, secretly, like a submarine. And then all the companies collected all those information from the automobile, all the hundreds of sensors with the location thing. Now, when the earthquake happened in 2011, then the people wanted to understand immediately that which bridge was broken, which bridge was not broken, for the safety of all the people suffered from a tsunami area. And then one of the person in the Honda decided by person that he's going to disclose all the Honda information without the consideration of the privacy or anything, because to save people's life. So then other companies, all the companies followed. So there was 5 information from the 5 vendors merged together because of the standardization effort before. So it was concatenated for the security, to rescue of those people. So that was one of the important point, the balance of the benefit and then the risk. This is 2 days ago, October 17th, newspaper said every single Toyota is going to be connected in those 2 countries. I don't know why. But anyway, so this technology is going to be used, and then other thing is 3D printer. I would like to talk about 3D printer. My university opened up a 3D printer for everybody, and it is connected. And then this is one of the brain science class, and then the professor said, scan your brain and bring them. And so everybody is on the first class, and then having its own brain printed, and then looking at the brains each other, and you are smaller than mine, type of thing. But anyway, so look at this site on the page. It said download this things button. So you push the button and you print it, and then this thing can be printed. This is a stupid thing, like 3 lines of letters together. But since it's open and it's shared, so it's very much a social network of the shared things. So immediately after the uploading the idea, then everybody in the world started to print. And then since this is a software, so it can modify it easily. So one of the German musicians created this one instead of 3. So now it's a kind of shared object thing. And I talked with the CEO of Yamaha Music Instruments, Nakata-san, that why don't you open all the data about your music instrument on the internet? If that is done, then everybody can print the Yamaha music instruments. How do you like it? And he said, no, then nobody is buying the Yamaha music instrument. I said, if everybody's play the music instrument, then eventually they're going to buy Yamaha music instrument. And he said, then he was convinced, but unfortunately we drank a lot of bottle of sake, so maybe he didn't remember it. But the point is that the delivery is not necessary, no customs and no tax and everything. So this is a kind of changing the way of things to be delivered. So this is also the impact that we are working. This is a 7 years research project we are having. So, and let me see how much time I left, but I wanna. This is one of my students working on a leg creation thing, and the leg is in a very big, large factory. They are creating it, and then different materials, and then the patterns of the legs is like the single patterns, different size, but it's not really the shape of the other legs. So what we are doing is scanning the remaining leg and reversing it and creating it by the 3D printer. So which can moving this factory with just a 3D printer and software. So this can be carried to everywhere in the world with a very inexpensive way to support the various people. So the different filament, and then the 3D printer is not that expensive equipment, just the size. So we do have a large size, and then delivering it to the everywhere in the world. That's the purpose of the very inexpensive way of the sharing the software is easy over the internet, and then so we are this is basically helping a lot of people. Personal fabrication things on internet is a different aspect of the Internet of Things as well. So the soft materials, medical materials, is also the important thing. And then if the things are shared, then another problem is the intellectual property and product liability things. But this is RFID printed into the things with a 3D printer, so that anything printed can be uniquely identified by the NFC RFID readers, and then of course referring to the database, so that any printed material is going to be also identified, and then this is going to be helping for the product liability things, because each of the things can be so we call it QIP, quality control, intellectual property, and the product liability for the things generated from the internet. This is NFBSDN, WebRTC. This is all familiar words for the networking thing, but maybe not on the glass to glass. It's a camera to the things, and the TV is a camera, and the TV screens are going to be very interesting. But before getting to that, then the protein calculation large scale was done with PlayStations around the world. That was the Guinness of 2007, which is the computers. Game is a thing. It's a computer really, but then it was over there. So this is your countries, not my country. But this was I heard that collecting from all the viewers' behavior, and they created, won the Emmy Award. So which is basically just stealing from the behavior of the viewers. So learning from the human being behavior and then creating the content. So that's a very new thing. So TV is one of the device on the area. So in Japan, TV is pushing a lot of internet technology and promoting the high-speed internet. Oh, by the way, the 10 gigabps with $100 per month started in June. This is pushed by TV subscription thing. So this is probably going to be a last example. This is very hard for you to understand. Maybe the cell phone companies collecting all the data with a registered subscription data because it's a postpaid, and then generating a lot of data. This is coverage is everywhere, and a very small ground station scale, and real time. So this is a very important big data to be analyzed, and then the people are talking. This is not not allowed, but this is done for the testing purposes. And we found out that the earthquake expecting on the Tokyo area, then we can be an evacuation process, and all the people, commuting from all over the neighbor prefecture to central Tokyo and going back, and then we can immediately identify that what kind of a move is happening in Tokyo, and therefore we can prepare for the earthquake disaster things. So this is also benefit risk. I mean, privacy risk is there, but the benefit is there. So there is an anonymization algorithm generated from the learning from all the national survey algorithm about the privacy things, and then we are utilizing it. So this is a lot of architecture with the NFB and the cyber physical things, as Chris said, and also the last three. There is a last week. Then one of the law group is very large actually. They collected more than 700 people 2 days, so more than 1,400 lawyers worked together to discuss about the new principle of IoT, big data, robot, AI type of things they started to discuss. So it's going to be very interesting. So this is again this slide, and then it's really important that the risk benefit balance, but a lot of actual things are happening. So thank you for listening.